Hey there, Math 20-1. So today we are going to, I think this is working just fine. I see some one thing there. We're going to go over this practice exam here. Really, this is just for people that want to see an explanation of why I did certain things. It is pretty long. Just check out the PDF if you just check out for the answers. Yeah, so let's get at it. All right. So we want to find out how many real solutions there are. So keyword is real solutions. There's some imaginary ones in there. In this quadratic system of equations. So it's already kind of set up nicely here. So what I'm going to do, assuming that my pen is going to work today, yeah, good. I'm just going to set them up. You see here, I gave myself a little bit more space than you. Sorry about that. But maybe use a scrap piece of paper. I'm just going to set these up here and subtract the two rows, right? The reason I can subtract these two rows is because the y's match up already, so I get 0 when I minus these two. There's a couple of ways to do this next part. We could just minus them as is, but nothing really stops me from putting this other one on top of this one. So I can actually minus upwards here to keep a positive. But I'm going to show you what happens if you have a negative in front. So negative 2x squared minus x squared is negative 3x squared. If I minus these, I have a negative, so actually you get a positive 5x there, and then I get a negative 8. Okay. Now, what you could do is just move everything over to the other side of the equation, because remember, Mr. Allen does not like negative x squareds. So I'm just going to move everything over to the other side here. And I'm going to stick with this. There. So now what we're going to do is we're going to try to either factor it. If we can factor it, then we have solutions. Technically, we have two solutions. But I quickly realized I can't factor this out. Nothing really multiplies out to 24. Oh, actually, did they actually factor? Positive 24 and negative 5. Positive 24 would be the best. If it was negative 24, it would work out. Positive 24 doesn't work. And what then we're going to do to determine the number of solutions, can't see it here, but I'm going to use my quadratic formula, but just the discriminant part. The square root part tells us a lot about this question. So I'm going to find out this part of it, the b squared minus 4ac. I don't care about the square root part. I just want to know what this number is. So my b here is negative 5 squared. My a is 3, and my 8 is c. So negative 5 squared is 25, positive 25. And then I notice over here that this number, 12 times 8, 96. This is going to end up being a negative number. 25 minus 96, negative 71. Because this is negative, we have 0 solutions. And I could have done that too by pulling out Desmos, because this is just a multiple choice question. So why do it this way? If I pull out Desmos, let's see what happens here. Or just a graphing calculator. I guess you don't have Desmos. But I can just see, you can't see it right now, I can see it on my other screen, how many solutions there are just based on looking at the graphs. Let me just type this in really quickly here. So look at my two graphs. There they are. A little bit bigger. They don't cross each other. They don't cross each other, no solutions. I'll just minimize that. We might need that later. Here we want to know which of the following are solutions. So technically, again, I could just graph these two, find the intersection points, and see what the solutions are. Or I can do this by system of equations, which I'm going to do, or by elimination or substitution, which I'm going to do here. So I'm going to go. Now that moving over trick that I did last time only really works if it's equal to 0. So this one's also going to be equal to 0. But what I'm going to do is I'm going to line this up a little bit nice. You notice that this bottom one has an x squared, but the top one does not. So I'm just going to keep my like terms on top of each other. That's really that straight line. Now here, there's nothing here. This is like saying, because there's no x squared, it's like saying 0x squared. So if I go 0x squared minus, because minus gives me the 0 y's, that's what I wanted, minus, this ends up being positive x squared. And then 3 minus 4, negative x. Negative 3 minus a negative 1, so negative 2. I should be able to factor this. You notice that all the solutions up here are nice. So that means that I probably should be able to factor this out. I've got negative 2 and positive 1. So my two solutions are 2 and negative 1. So I have two solutions. And if I have two solutions here, there's no extraneous. So you get the extraneous solutions in absolute values, not in system equations. You get the two solutions, you get two solutions. You just have to figure out which of the two. It looks like I have over here, I got one with negative 6 and then one with a positive 3. And oh, they mixed them up. See, this is why I want you to be organized, because those are all the right numbers, but do they match up? Right? So if I put in a 2, let's just do the 2 into the first equation, what do we get? We get 6 minus 3, we get 3. So the 2 corresponds to the 3. So that's this one here. So I'm assuming it's going to work out for this. You can just double check. I put a 3 in there. That's negative 3 minus 3. It's negative 6. So this one corresponds to the negative 1. So check mark there. So don't just write them out willy-nilly. Like if I'm going to write this as my written response, I would say x is equal to 2 and y is equal to 3. Put a box around those because they go together. X is equal to negative 1 and y is equal to negative 6. Put a box around those. Okay? But don't just mix them up. Be very organized about how you write your solution. Like I said in class, I will be dumb if you don't do this. If you just put a bunch of x's on one side, a bunch of y's on the other side, what just happened to that thing? I will purposely mismatch them and mark you wrong. Maybe not 100% wrong. You did get some of the right answers and some right numbers. You got part mark off, right? So be very careful. This one here, there's a couple ways you can actually graph this and see where these dots are, but it'd be nice if the dots were already on the graph. So I might as well just test it. So I want to know which one is true. So let's see what the first one says. Nope, I don't know what I just hit there. Oh no, did I just break it? Ah, there we go. I didn't quite break it. So I put a 2 in this spot, and then over here I put a 3 in the y spot. That's my x. This is my y. And I want to know if that's less than 6. Obviously, this one is not. 9 plus that's 11 is not less than 6. Cross that one off. I'll just keep on going. This one is going to be, is 6 less than 6? No, 6 is equal to 6. If there was an equal sign there, this would be true. That didn't work out very well. All right, let's see. I like having negatives in some of these spots because that's going to bring the number down. But this one doesn't bring it down enough. This ends up being a 9. So that's not true. Process elimination should be the last one. Let's just double check. I put a 1 in this spot. That's negative 6. 1 minus 6, negative 5. Is that less than 6? True. My answer is D. All right, so I just go through and just check them all. All right, one at a time. Doesn't take too long. Right, it's a little bit of a lot of work there. All right, so this one's this is very similar to one we just did in our pre-test here. We just like to look at this symbol right here and see which one matches this graph. The pre-test one didn't have a bunch of letters in here. Technically, you could actually just put numbers in and see which one works. But because it's not equal to, I know that it's not these because this has a solid line to it. So this here just means it's a dotted line, right? So it's got to be either B or C. And because it's greater than, greater than, it's going to be shaded above. And the one that's shaded above, this one here, if you notice that you draw lines above the graph here, that's shaded above. All right, because of the greater than. This would be a less than shaded below graph, right? So if I switch the sign, it would have been that answer. Oh yeah, so this is kind of weird. Sorry about this. I think it's just because of the when I change fonts, it changes characters. But down here, it tells us what the inequality was originally. Okay, so she starts off, I'm assuming that this is where she starts. Okay, let's figure out where she went wrong. So she minused, she looks like she minused the y and the 8 over, so that seems like pretty good. In negative, so that, yeah, this seems okay to me. This turns to negative, that turns to negative, looks good. We divided by a negative. Okay, so that's good. We divide by a negative. You notice that when she divides by a negative, her symbol flipped, which is good. I like that. But the problem is, here I got a negative divided by a negative. It's a positive form, so that's good. But the problem here is negative divided by negative should be positive. A little sadness there. So I made a mistake in step 4 here. Like everything good was good up to that point. It's that negative should turn to positive. I don't know why she didn't do that. Rachel. So here we have a rock thrown upwards, blah, 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 by this equation, blah, blah, blah. We want to know when this is greater than 6. Okay. Because of these decimals, I'm just going to graph this one. So no, I'll call it Desmos, and we'll see how the solution looks. But they're essentially asking this question. When is this equation greater than 6? It just says greater than, not equal to. So greater than 6. I'm just going to actually cross up B and C because they put little equal signs there. It's greater than, but not equal to. Okay. What I would do in this question, if I could factor it, now, like I said on the test, I would have just factorable questions. Ooh, I missed a negative here. That's a, I don't want to do that. So that's going to change the way I approach this question. There's a negative there. So I'm going to actually add or minus these things over to the other side. So I have a positive t squared. So rather than negative 4.9, I have a positive 4.9 there. And minus the 14 over 14t, and then this is still this plus 6 from before. Now, I would try to factor this. The problem is that 4.9 is going to cause some problems with our factoring. So I would actually, at this point, for Desmos, and graph, actually I just graph my original graph. So y is equal to 4.9. So just graph in your graphing calculator here, because it's multiple choice. I don't care about the work in this case. I don't know what the t is. It seems like it is. X is there instead. And I want to know when this is greater than 6. So what I'm going to do, it's kind of like a system. You graph the left side, you graph the right side. You want to find out where they intersect each other. So this is before I modify the graph. So here's what it looks like, right? And I want to know when this red graph is greater than this blue line. So you can see it's this piece up here. So from those two dots, like if I made this equal to 0, you'll see what happens here. It's these two dots when it's actually greater than 0, actually less than 0 in this case, if I flip it over, but it's going to be these two dots here and everything in between. So the 0.53 and the 2.33. So the A. And because it's everything in between, if I did like a number line, it would be everything in between. It would be written this way. So I'm going to put down here for the sake of PDF. Okay. So this is a nice number, so I should be able to do this one without graphing it. Technically, I could just graph this, find out when it works. Actually, I don't even have to graph it because I can see what's going to happen here. The first thing you want to do when you isolate or solve for absolute values is to isolate for the absolute values. So I'm going to minus this 6 over and get -9. And then I look at this and say, can't do it. Because the absolute value, after I do all this math, the absolute value is going to turn this number positive. How can it ever be negative? Right? Can't be negative. If you were to graph this, you just see that the lines just never cross each other. I should graph this out. You'd have to find that absolute value button in your calculator, math or something. You can graph them and then put a little -9 in here. Oh, -9. You can graph the original one too if you don't trust that. And then I'm just going to zoom out a little bit. There's my two lines. They'll never cross each other. Okay, so I'm just going to minimize that back up. Now I'm going to put down here always positive. No solutions. All right. Oh, I thought it was really the same thing, 2x plus 8, but this is 2x plus 3. So when you create a piecewise function, remember piecewise functions like this one of Desmos here, it's made up of two pieces, two graphs, a positive graph and a negative graph. You notice this one has a positive slope, this has a negative slope. Same thing with the quadratics, positive quadratic and a negative quadratic. It's made up of those two pieces. You just have to figure out when do I use them. So you notice that most of these are correct. So the positive version of this is 2x plus 3, 2x plus 3. They all have that part. But the negative piece, that's this piece here, is going to be the negative of this graph, which means all the signs flip. So this one here has a problem, right? So it can't be that one. Didn't flip. All the other ones had this right equations, but now they have different x-intercepts and different directions for them. So what I want to do is I want to kind of draw this out. The graph is going to look somewhat like this. It's going to have a 3 here. That's going to be this would be the 2x plus 3 one. So that's the 2x plus 3. And then this graph, part of the graph here, this would be the negative graph, 2x minus 3. Okay? This piece right here is what I'm looking for. Where does it switch between the two? So it looks like it's either going to be -3 or -3/2. But to find that, that's just the x-intercept. So I make y is equal to 0. Let's just pick the original equation here. Minus the 3 over, and I can quickly see that it's going to be the 3/2 one. So I'm going to cross off C. And these numbers don't make any sense. So now we have to figure out which side do I use. So the positive one, if this line is x is equal to -3/2, I use the positive graph greater than this one. So let's go back here. Positive is greater than. Awesome. Not less than. Oh, so I cross this one off. That's a bad sign. I don't like that. So A, and then double check. Yeah, I use the negative one less than. There we go. Answer's A. Again, this one I could graph as well. All right. Looks like maybe I'm going to get 2s or maybe -2s, and then maybe I'm going to have to actually verify to see whether or not this solution actually work. Actually, technically what I could do is just put these numbers in there and see if they work. Like put x equal -2, does it work? 2 doesn't work, -4 doesn't work. And then from that, I can just eliminate my answers. But I think it would just be a little bit nicer to actually show all the work. What if I didn't have choices, right? So remember, it's always made up of two graphs. One graph is my positive graph. That's my positive graph. One graph is my negative graph. I'll show my negative graph here. But you notice the absolute value side, that's the only side that changed. The other side does not change because it's not an absolute value. So that's just a line that's always there. It goes, extends forever up and down. Okay. Then what we're going to do is we're going to rearrange these ever so slightly. I'll keep the x squared here. So minus the 3x over. Oh, gone. Right? And minus 4 as it goes here. Oh. So technically, it's a difference of squares. So you could factor this. But because it's just a single x there, I'm just going to rearrange it for x. Take the square root and get +2 and -2. Okay, so that's really doesn't help me too much. I'm going to have to verify that. Figure out, do both the solutions work? Then I go over to the other side. What I'm going to do on this one is rearrange it the other way. I'm going to take this and put it on that side. Add those in. Oh, we got 6 this time there. And add that on -11. Okay. Is that factorable? prime number. I'll pull my calculator here. At this point, I'd be like, okay, can I actually factor this? Are there any solutions? I graph it. Uh-oh, it doesn't cross the x-axis here. Yep. There's no solutions to this side. So I don't even know where they would get the 4 from. I'm just going to cross that off. My only choices here are 2 and negative 2. All right, so let's put that in here. So let's do a little verification. All right, so I'm going to use 2 to start off with. I'm going to put 2 squared plus 3 times 2 plus 3. Is that the same thing as 3 times 2 plus 3, or 7? So 6 plus 7 is 13. And then 4 plus 6. 4 plus 3 is 7, plus 6 is 13. Absolute value 13. Yeah, check mark. So 2 works. Cross off A because it doesn't have a 2. But now my choice is, does negative 2 work or not? Let's verify negative 2. Seems like negative 2 is going to work. Let's double check. Negative 2 squared, 3 times negative 2 plus 3, and then 3 times negative 2 plus 7. 3 times negative 2 is 6, plus 7 is 1. Negative 6, sorry. Plus, that's positive 1 there. 7 minus 6 is another 1. Absolute value 1. That works. So my answer is C. And both of them work. Cool. No, I'm just going to hit here save as. Just 1 second. Charlie. Add on to the video here. Okay. Oh, yeah, this is a good point. Okay. So remember, when you take the absolute value of a graph, all you're doing is taking the absolute values of just the y values, not the x values. So if, like, say the y-intercept is -7, now it's going to be +7. So it's just going to flip straight up. So if I take the absolute value of this graph here, I'm going to just change the y values of this point. So -4, -7 comes -4, +7, but the -4 stays the same. So it'd be B. You're essentially just taking the absolute values of just the y values. I'm going to write that down here because some people might just be reading the PDF instead. Okay. To the nearest 10th, the sum of the x coordinates. So I just had to find just the x's apparently. So I have to solve for x. So it looks like I'm just going to minus these 2 rows right away, actually. Actually, I'm going to write those down. That numerical box is right in the way of my minusing. That's it. Let's see. Minus these, I'm going to get 0 here, which is good. I don't have to modify these equations. Minus a negative, so this would be 2x squared minus another negative here, so I get -3, because it'd be technically adding 2. And then 4 minus 8 is -4. Okay, then I look at that and say, what multiplies out to mess up somewhere? Probably not. What multiplies out to -8? It adds to 3. I don't think anything does. No, nothing. But because of that, like I said on the test, is not going to be a situation where you have to graph it. But in this case, I am going to have to graph this one just to see if I made a mistake, first of all. If I'm just going to graph it, I can plug the other calculator. I have Desmos for a reason. All right, if I'm just going to graph it, let's just graph the original equations. Make sure I didn't make any mistakes. I graph my original equations. Y is equal to x squared minus 5x plus 4, and then y is equal to -x squared minus 2x plus 8. Look at my intersection points. Oh yeah, they're not very nice here. And I add them together. That's a shame that they're not very nice here. So let's just write these down here. So not factorable. It is solvable. I could use a quadratic formula, but I'm just going to graph these, find the intersection. So x is equal to negative 0.851. And then we have another x equal to 2.351. And then minus these two numbers, or sum them together, I guess. Add in a negative though. Is around 1.50. What does it say? To the nearest 10th. Add them together. 1.5. Or that little symbol, it's a sigma symbol. It stands for the sum. But let me just saves all of a sudden. I have a button that saves. The problem is, once you get to a certain size of document, it takes forever. All right, good. Oh, now my pen's all messed up. Sum of, okay. Let's see what we have here. Fireworks traveling around. When if x equals the horizontal distance, vertical distance, what are we trying to find? Launched from the platform at the base of the hill, at the top of the platform, using the top of the platform as the origin, taking some measurements. It was determined that the cross-section of slope. What the hell is this? And when does it fall back on top of the hill? Okay, that makes sense. It's just a system of equations. I know there's a lot of words here. Our reality, we are just doing a quick little system here. Notice here I've added a little bit of space here. So if I am going to solve this system, I kind of want to line up my like terms. If here I have 0x squared, so 0 minus negative 1, or I should say 0, is positive x squared. Minus these, I get negative 11. And then minus that, nothing, get negative 12. This should factor out to negative 12 plus 1. But then you realize that negative 1 doesn't make any sense. And here's the whole number, the horizontal distance. So this is the horizontal distance here. So x is equal to 12 meters, I assume. There's a lot of words in this question. Oh my God. Actually, it doesn't say, does it? Units. It doesn't say. Yes. Now, you could have done that by graphing as well, because again, it's just a numerical response. I did algebraically. It worked out. These ones you want to do algebraically as well. There's a few of them there. Oh man, there's a lot of questions here. Ooh, keep it going here. All right, so algebraically doing these questions here, these are nicely lined up already, so I might as well just minus them right now. 0, x squared minus nothing, just x squared. Negative x squared minus x is 2, negative 2x. And then negative 6 minus a negative is going to be negative 3, because you're technically adding 3. And I factor this out. 3, 1. Okay, and then I got 3, I got negative 1. And then we put that back in. Remember, you had to find, you got to find the y values to go with these. So my 3 minus 3, I'm just going to put it back into the second equation here. So y is equal to 3 minus 3 equal to 0. There's one of my answers. Right? 3 and the 0 go together. If you want to, you can write them as an ordered pair if you find an intersection. But keep them organized. Then I'm a -1 here. I'm going to put it back in this. I trust that these are right. I'm just going to assume. Yeah, that's -1 there. Minus 2. So that, why did I put a line there? Let's put it there. -4. Okay. So this would be -1, -4. You can verify those. You can graph these. These are pretty easy to graph because they're already equal to y. Find out these intersection points. Do they match? Again, we want to do this algebraically, so we want to show all that work. Okay, I'm going to minus these two as well, because you can see y minus y is going to give me a 0, which is nice. Minusing a negative, that ends up in a 3 there. Minus this, it ends up being positive 3. And minusing these ends up being 0. You can put plus 0 if you want, which is nice, because then this is a much nicer thing to factor. Remember, the first thing you always do to look, or when you're trying to find factors or factoring, is always look for that GCF. And notice they both have a 3 in common, and they both have an x in common. So I'll factor that out. Plus 1. Yeah, so when I factor out the 3 and the x, remember you divide them. 3 divided by 3 is 1. X divided by x is 1. 1 times 1 is 1. So I have this plus 1 here. You always want to make sure that when you multiply this back in, you end up with the same thing in the top. Looks like it will. Okay, cool. What would make this equal to 0? Well, -1 for sure, that's the brackets, and 0, very important, that this x is right here gives me that 0. Then I do the same thing. Oh, these are a bit more tricky equations. I'm going to put -1 into the equation and try to determine what the y value is. Now again, I don't have to do it for both equations. I just have to do it for one if I trust my answers. Hold my calculator here. 2, oh, I get 0. Okay. 1 equals 0. So that's 1 point. -1 and 0. Okay. And then I'm going to do it again over here. Get x equals 0. Well, this is much easier. X equals 0. Y is just going to be 3. Awesome. I'm done. And if you want to put that as a point, you can. 0. Okay. Awesome. Awesome. Next one. Oh, I'm going to have to rearrange a little bit here. Plus, what I'm going to do here is I'm going to avoid fractions as much as possible. Because you notice my y's are not the same. So rather than dividing everything by 2, I'm actually going to times one of the equations by 2 to make them the same. Because if I divide by 2, I might get a fraction. I don't want that. So first of all, I'm going to rearrange them. So at least they look very similar. Maybe get the y's by themselves. So I'll have the first equation, I'll have 2y is equal to x squared minus 1 plus 1. So I'll add over the 1 to that side. Here, I'm going to leave the y on this side, and then move everything else over to the other side. That's what it looks like there. What I'm going to do now is I'm going to take the second equation, times it by 2. Then I have this new equation here. Okay, so 2y. The whole goal, I guess I could just minus the y over the other side, but the whole goal is to make the y's at least have the same number. They don't have the same sign. They don't have to, but they have to have the same number. So I can either add or subtract to get rid of them. In this case, I made sure that they had the same sign for some reason. I'm going to times by 2. It looks like this. Times absolute everything by 2. Divide, or minus here, so minus that. Oh, minus in a negative. So this will be 3x squared minus that one will be another 3. And I'm adding, essentially negative, adding, so -1 plus, yeah, 3. And minus, so -5. Okay, once we get to that point, I'm going to factor. What multiplies, I'm just going to do the factoring. I'll do the factoring up here. What multiplies out to -15, that adds to 3. Can I factor this? We will have ones that factor. I'm just going to double check it to make sure I have math right here. Added that over, minus that over. Times everything by 2. looks pretty good. All right. Gosh, I'm just going to graph this and see are my solutions nice. All right. Hey, how's it going? It's good. Oh, I'm actually going to graph the original ones here. Original graph. Sorry about that. You can do that. Answers. Yeah, they're not nice numbers here. Okay. It's not factorable. So I'm just going to use my quadratic formula. E plus or minus the square root of b squared minus 4 times a times c all over 2a. 2 times a. Okay, let's see what we have here. Minus 4 times 3 is negative 5. There. 6. And I'd stop there. Like if you were to type it in, you should get the same answers you get on the calculator. Yeah, sorry. I'm not talking to myself. Yeah. Okay, some word equations here. I'm going to skip past number 2. First between two numbers is 6. The square of the larger number by 17 times the smaller. Yeah, I'm not going to ask a kind of question like that on the test. I'll skip past that one. This one here, you probably want to do it algebraically, but it's just another systems equation. So we're going to run into a thing where we have too many systems equations. I'm going to skip past these two. This one, question 6, is a little bit tricky. I'm going to skip past that. I'm just going to write this for the PDF versions here. Skip it. Skip it. We really want the solutions. You can come see me tomorrow or something. Skip it. Okay. Skip this as well. Skip it. Skipped. Oh, this is a fun question. It's just I don't want to do it. Okay. Yep. So I'm going to do the next few. Oh yeah. This is a really long thing. I hope I get this finished before the bell rings here. Absolute values. We're going to do a couple of those already. Expresses a piecewise function. I'll definitely do that. Give them a sketch. What is this? Oh, determine the absolute value. Give me the domain range. Let's just determine the sketch. This is labeled 2 points. Okay. Easy-ish. Okay, so let's go back here. So we're not going to. We're going to go do the rest of these. 7. So we want to sketch this. So this is kind of nice. It's already in the form y is equal to mx plus b. So my b is -4. So that means I'm going to cross at -4. I have a negative slope. So remember, negative slope is this way. Positive slope is that way. Please don't get those mixed up. That's just a shame if you do. Okay. So since it's negative slope, I'm going to go down 3 over 1, down 3 over 1, down 3 over, and then backwards. I just follow the pattern, but reverse it. All right. And then because it is not equal to, we're going to use a dashed or dotted line here for my equation. Oh, this is really hard to do in this drawing program that I have here. But that's essentially what the line is going to be. So it's going to be nice and dotted. Oh, crap. Okay, there we go. And then I'm going to pick a side to shade because all my solutions are kind of mixes of x and y's to make this work. So I know right now the line does not equal the solution. That's why we use dotted. So any dot on this that I drew here will not make this true. But because it's less than, I'm going to shade below the graph, right? I'm going to shade all of this area here. I don't know it's true. It always will, right? So these are all my solutions in that little shaded area. So based on that, I know what the inequality symbol for these two things are going to be in the next graph. So because they're shaded below, that's less than. This one's shaded below, that's less than. So I know for both of these, it's going to be less than or equal to. This is nice and solid, right? So this would be y is less than or equal to. Now this is nice because it's the linear line. So if I do the y is equal to mx plus b formula, I just need my slope of my y-intercept. My y-intercept is 2, so I'll just put a 2 there. My slope, it goes up 1 over 2 to the next dot. So it'll be 1 over 2x. We're done. Perfect. This one here is a little trickier because I got to determine the a value and the p and the q. My vertex is my p and my q. So my vertex is -3, 5. Okay. So what we know so far, so I'm going to solve this one using this formula here. Minus p plus q. So I'll fill in what we know. We know p negative, so negative turns positive. And q is 5. Okay. It looks like a has to be negative. Is it -1? Is it -2? Highlighted this point for a reason. So I'm going to use that point. So if I put a -2 in, I'm going to put this on the side down here because I'm going to write my answer here in that spot. If I put my -2 in, I need to get a +2 out. That's what it's saying there. So I'm going to put a -2 in here. And a +2 out here. Okay. Minus the 5 over, get a -3, which is a good sign because it's negative. This is going to be 1 squared. Oh, it looks like a is going to be -3. So I'll just divide the 1 squared, which is 1, over to the other side. Okay, so we know the equation. I'm going to write it out here. There we go. Put a box around that. Seems like a lot of stuff there. Cool. Solve the following. It says here, include your number line and the interval solution. Now let's make that set notation rather than interval notation. But I want to solve this inequality algebraically. I guess I could graph it. That's a good verification. But what I'm going to do before I start the question is think, okay, I got this negative I don't want, so I'm going to actually rearrange the equation. Now, if all I do is add or subtract, I don't have to switch my sign. I'm just going to minus the 8 over, add the 15 over. That's all I do. Okay. Then we're going to factor it. You know, so we can actually factor this. There's a 3 and a 5 here, and both negative would work out. Determine what would make this equal to 0. Throw it onto a number line, x number line, 3 and 5. Decide what kind of dot to use. So I'm going to use hollow dots here. And test a point. I'll test 0. This happens to be over here somewhere. Always go back to the original to test it out. So is 0 minus 15 is -15 greater than 0? No. No, not good. Okay, so my answer is going to be in between these two. I just test x equals 0 and -15 greater than 0. False. That'll start. Go back to code. All right. So it's in between these two values. So I got 3 and 5. And my x is in between the two. That's how I represent that solution. Seems like my my verification went into the other question, so I'm going to have to erase this little sad face here instead. Okay. Now we do the same thing. This one I don't have to rearrange, but maybe I would think about, okay, is there some number I could factor out of this to make my life a little bit easier? I don't know if there is. No, can't divide by 3 and can't divide by 2, so we're stuck. So now we just have to try to find something to factor this out. I'm hoping it is factorable. Like I said, I'm going to create questions on the test that are factorable. I'm looking for answers here that multiply out to 144, positive 144, and add to negative 24. You're just kind of watching me do the work here. Ooh, 18 and 8, two negatives. 18 and 8. No, that wouldn't work, is it? Damn it. 18 plus 8 is 26. That didn't work. Well, okay, I'm just going to erase that. That didn't work. What else can I have? Let's see, 144 divided by 144 divided by that. Ooh. Oh, 25. 69 that didn't work well. Divided by that. Oh, you know what? 12. My Lord, I can't believe I didn't think of that. It's a perfect square. 12 times 12. Well, it's negative. That's perfect. Okay. So, ooh, this is interesting. This is only one answer. Okay, so I got 9x minus 12. 9x minus 12. I'm going to reduce those down. So remember, I'm just using a different method here, called Joe's method. I divide them both by 3. So I get 3x minus 4. 3x minus 4. So I have one solution, 4 over 3. So if I put this on my number line, right there, there's my number. There's my dot. Then you get to think, okay, quadratics have this kind of weird thing where it goes in and out. So how do I plot this? What do I do? Well, what I'm going to do is I'm actually going to test both sides of this equation. Right? I know 4 over 3 works because it's equal to that. So if I go 4 over 3, I can get that. But let's just test like something over here, maybe 0. So if I test 0, I get 16. Is that greater than? Oh, wow, it is. So this side is true. Everything on this side should be true. But then I look at the other side and say, okay, that side's true. So what's the number bigger than this? 2 or something. Let's test 2. Like up at the top one, I should be testing in all these different spots, but I can recognize the pattern. But this is a weird one. I put a 2 in there. So that times 4 essentially, minus 24 times 2 plus a 16. You have 4. 4 is 4 greater. Oh, it is true. These are both true. Oh, whoa, this is weird. And there's not even a hollow dot here. This is actually a solid dot, so it includes this. If it was a hollow dot there, it'd be pretty much everything but that dot. But because it's solid, it's everything. My number line is just full up of all solutions. My graph will always be bigger than 0. That's not fair. I always want to see what that looks like. See if that's true. So if I graph this, I want to know when this graph is bigger than 0. Oh, graph is always bigger than 0. It's all about the x-axis. So this graph is always going to be greater than 0. It's always positive. So how do I write that? My number solution? Well, x, e, r, everything works. Maybe not imaginary numbers, but at least real numbers will work. That's a fun, unique case. I like that one. Let's graph these ones here. So these are inequalities again, but they got some symbols here. You got greater than or equal to, this one's greater than. It would be nice if I switched them up. Good thing about some of these, like this one here is in vertex form, so I know where the vertex is. It's -1, +4, so I know that much. -1, +4. It's opening down. It's going to go downwards here. Right? I'm going to use a solid line. Graph this. I'm going to shade above. Right? So I'm going to have a lot of shaded area here. But I need to know the x and y intercepts to create a proper graph here. I want to do this kind of algebraically here. So I'm going to make this, actually, definitely do it algebraically here. So to find the x-intercepts, make y is equal to 0. Let's do that. And start rearranging this. Minus that over. Can't take the square root yet. So I'm going to have to get rid of this negative here. So I'm going to minus the negative, or divide the negative. So it turns to positive there. Percent, because I couldn't take the square root before. Then I take the square root of both sides here. Because I do that, there's a plus and minus there. Let's see what we have here. We've got +2 is equal to x plus 1, and then we got -2 is equal to x plus 1. So I got x is equal to 1, and x is equal to -3. Okay. 1, -3. That's symmetrical. You can see that it's 2 away from this axis of symmetry on both sides. So that's good. Y-intercept. So to find the y-intercept, I'm at x equal to 0. I'll put 0 into this equation here. Why am I having troubles with my mental math? Oh, I'm not doing mental math right now. 0 plus 1 squared plus 4. -1 squared plus 4, 3. My y-intercept is 3. Okay. Now, once we have our y-intercept, I can see some symmetry here. With my axis of symmetry is 1 over here, so it'd be 1 over there. I'm going to use a nice solid line here to draw a horrible parabola. Oh my lord. Let's undo that line there. Let's try that again. Oh, okay, when I hit undo, it jumps around. Down there, where am I? Okay, press the right spot this time. Pen out. And then start drawing this a little bit better. Oh, I almost missed it, but that's not too bad. Now again, I'm using a solid line, and then I have to decide, okay, how am I going to shade this? So, because I'm shading is greater than, I'm going to have to shade above all of this area. Nicely shaded. Perfect. There you go. If I want to test the dot, but there's a pattern. Holds true. So this one here, find my x-intercepts, I probably want to factor. One would make this equal to 0. Those are technically not part of my solution, so I am going to use a dotted line here. Let me just put that in here. Dotted, okay. So we have 4, we got 2, -2, and a +4. So that makes -4 and +2 my answers. +2, -4. Okay, so I know my x-intercepts. My y-intercept, that's a pretty easy one, is -8. Right, remember, when it's in this kind of form here, with not in vertex form, you just put zeros in there, and the last number just pops out. -8. Okay, so my axis symmetry looks like it's right about there. That means I have another dot right there. My vertex is somewhere on that line. All right, it's probably gonna be down here. Somewhere on this line. So what I could do is I could just put that value into the equation to find out the y value. I put 1 in there. So 1 plus 2 minus 8. I get negative. Oh, that worked well. What did I mess up on? We got -5. Oh, -1. So that's where I messed up. Oopsie. That makes more sense. Negative 1. 1 minus 2 minus 8. Negative 9. Negative 9. So that's where I know it is down here at negative 9. But to find it out in a different way, complete the square. So let's complete the square. A nice little 3-step method here. My A value is going to be 1. That doesn't really do too much to my graph here. Oh, it's probably a plus there. I'll figure that out later. So we'll go x squared plus 2x minus 8. I take this middle term here and divide it by 2, so I get the 1. I multiply it back out. Get 1 again. So 1 times 1 is 1. So add 1, minus 1, pop this out. Negative 9, negative 9. So negative 1. So that's exactly what I thought it was going to be. There it is. We use a dotted line. We've got dotted lines. You can correct your mistakes as you go. And then shade the appropriate region. Greater than, so I shade the inside this time. That is above the line. Always above, below. Never like inside, outside, or left and right. Just above and below. There you go. Looking good.
Good afternoon, no. Staff and students. As we come to the conclusion of our day, we please ask that you stand where you are and join me in the end of the day blessing. In the name of the Father, and of the Son, and of the Holy Spirit. May the Lord bless you and keep you. May the Lord make his face shine upon you and be gracious unto you. May the Lord look upon you all with favor and grant you peace. Amen. In the name of the Father, and the Son, and the Holy Spirit.
Cool. All right. We're going to solve these algebraically. Very similar to one of those multiple choice ones there. You got the two cases. You got the positive graph. You got the negative graph. Okay. You got, or sorry, that's the positive graph there. Then you got the negative graph over here. Okay. And then we just solve for x. But remember, always verify. So what are we going to do here? I'm going to swap the spots here. I'm going to add the 5 that way, add the 6 this way, and divide by 6. I get 1. Then I go back here. 1 is not going to work because negative 5 ends up on the outside. So if I do a verify here, verify, I'm going to get absolute value of 1 minus 6, which is negative 5. Then I get 5 times negative 1, or 5 times 1. So the absolute value of negative 5 is not equal to negative 5. That's equal positive. So they cross it off. Don't erase it. Circle it and cross it off. You did the work, but it didn't work. So here I'm going to minus over the 6 this time. I'm going to add over the 5. So I get 4x. Divide by 4. Reduce it down, and then verify it. Now this one looks more promising because it's got negative, negative. It'll end up being a positive, at least on the side. So I'll pull my calculator here. So negative 5 times negative 3. Oh, sorry, that didn't work too well. What am I typing here? With negative 3 over 2. So on the right side, I get 7.5. That's on the right side there. Now I'm going to do the same thing. I got negative 3 over 2 minus 6. But remember, this one's in absolute values, so it turned to positive. So this should work out. Sweet. I'll put a little box around that. Check one. Actually, not on the calculator. Verify. Yeah, I'm not going to do it. Okay. Verify. It worked. Do the same thing. So again, we got the positive graph here. It's just the absolute value side you have to do this for. And then this quadratic that I was trying to collide with. And then I got the negative graph over here. I don't think I gave you any space to do this question. But then we rearrange it. I like everything on the right side now because both of these have x squared being positive on the right side. So I'm going to minus this over. and move everything that direction. So x squared, x minus x is 0, -9. Oh, they can rearrange it. We're going to add the 9. It's a quadratic. It's a difference of squares, but just rearrange for x. If there's only a single x, rearrange for it. Take the square root of both sides. Get two answers. 3 and -3. I'm going to have to verify these. Let's go over the other side first. I'll just pull my calculator at once. Add over the x, I get 2x this time. Add over this, I get a -5. Oh. 5 is prime. This is garbage. Okay. This is garbage. Yeah, I'm going to have to either use the quadratic formula. It says here, algebraically do it. Like I said, I'm going my best to give you answers that are factorable. Yeah, I'm going to use quadratic formula. B squared, 2 squared, this is 4, minus 4 times A times C. There are solutions to this one because the discriminant is a positive number. It's not the nicest numbers in the world. Let's see what we got here. 4 plus 20, 24. There's my two answers. Now, you know how I'm going to verify this? I'm going to graph it. There's a very simple way to verify this. So I can graph this by just taking the absolute value. So I just go to math there, go to num, and there's ABS there. Type in x plus 2. Poop. Oh, there's a little AB button there. I didn't know that. Yeah, pretty cool. X2, okay. And, oh, I hit enter on that one. And then x squared plus x minus 7. Okay, graph. There's only two answers here. You see one here, and you see one over there. So which of those? Looks like 3 is one of the answers, and this is probably one of those ugly answers over there. The other ones just don't work. The other ones are like here and over here. Okay. So to find those answers, I can go second trace number 5, enter, enter, enter. Yeah, 3 is one of the answers. Second trace number 5, enter, enter. And then I'm just going to go over there a little bit. It's going to put -3, but not going to be -3. It's going to be -3.45 or so. Okay. So 3 doesn't work. And then the one that's here, that's approximately like -3.45. That's the one that works. The other one doesn't work. All right. Express this as a piecewise equation. So do this as a piecewise. I've got to first of all find the x-intercepts, because that's going to be part of my answer. Make y is equal to 0 here. Solve for x. It's a quadratic. Actually, if I factor this, I would get something that looks like this, because it's the difference of squares, and I have my two answers. But I could have got these two answers by rearranging for x, taking the square root. And you remember, you take the square root, you get two answers. So I have these two equations now, or actually this equation. So I have the positive equation, and the negative equation. And then when am I using each of these? I'll put little if statements here. So I want a little sketch of what this looks like. So I'm going to just put the sketch kind of over here. So we have a quadratic that's going like this. That's the x squared minus 25. And then we have another quadratic like this. That's the negative x squared plus 25. And our absolute value is just this piece here. So that is. So we are using that. We're using the positive one on the outside wings there. when x is less than -5, or when x is greater than 5. Okay, and we're using the upside down one in the inside there, so in between -5 and 5. Cool. And one of these should be equals, and the others should not. Cool. This one here says sketch what it looks like and says label some points here. So when I do the absolute value, I'm just doing the absolute value. Let's do a different color here. Of just the y value. So this part of the graph stays the same. This part of the graph stays the same. And all the other points flip up. Like this one here is like -3. That's -3. So now they're +3. This one here is -4. So now it's +4. And then I can just draw my parabola to match. Now the domain of that graph was the domain of the quadratic, so XER. But the range now is going to be greater than or equal to 0. Now it looks like it does keep on going up. If it doesn't go up, then maybe we can just stop at 6. But let's assume that it goes up. If it touches the edge of the screen, it continues on forever. All right. I will get this PDF on this classroom there, and I'll post the video. Obviously, if you're watching this video, you've already seen it. Okay. See you later. Bye.